Hey everyone, it is time for a bonus recitation. This time I just wanted to go over async await a little bit and also how to use it in the context of the projects we've been writing for the first part of the Node curriculum. Today I'm starting off with a modified version of one of the guided projects from last week. I've dropped a link to that in the Web21 After Party channel if you'd like to follow along. And I'll also be posting the the resultant code in this inside of a recitation branch. So basically, yes, this will be recorded. This is being recorded, in fact. So basically what we have here is I already have my project yarn installed and started. And we have the same setup as we've kind of consistently had, where we have a server, an index.js that implements that server, adds some middleware, and listens on some port. I've also set up a router for us inside of the hubs router file. So if we go into hubs and then router, here's our router. And the setup of our data is that we have hubs and messages, and a hub has a name. And it can also have messages associated with it. And the messages have a name, description, I don't know, they have some fields. We'll figure it out as we go along. And I've written a couple endpoints already. One to go ahead and get all of our hubs, and one to get a specific hub. And I have these being tested out here in Postman. We can get the hubs. We see they really just have a name and an ID. They also have our timestamps. And I should also be able to go and get a specific hub. Oh no, I've gotten an error. That's because I did code bad. There we go. So now I can get a specific hub as well. And this should look fairly standard to you. We're using our hubs model that is kind enough to already exist in order to get all of the hubs. We're doing hubs.find, then catch, find by ID, same thing, then catch. And this is generally how we write asynchronous code in JavaScript. And by asynchronous, what I mean is that when we execute our hubs.find, which returns a promise, that code essentially gets put into the background. And it doesn't run in order. It's asynchronous. The order in which it runs, we can't entirely be certain on. It's not synchronized line by line. But there's another way of handling asynchronous code in JavaScript, and that's called async and await. And these are two specific keywords that we can apply to our functions and lines of code that we run that allow us to handle asynchronous code, to handle promises in a way that looks much more like procedural JavaScript code, line by line. So I'm going to convert this get route into async and await. The way we do this is when we declare a function, we have to add an async keyword to it. And this tells JavaScript that this whole function is going to be asynchronous. And this is automatically going to treat this function essentially as a promise. This function will always return a promise. And now within here we can use the await keyword. So normally hubs.find returns a promise, and if we want to do anything with the resolution of that promise, we have to do a .then or a .catch. Well, with the async keyword, I can say const hubs is equal to hubs.find. Right? What this does is it puts hubs equal to this promise. I don't want it equal to the promise. I want it actually equal to that hubs, that array of hubs. I know we've all been in that situation where we're like, ugh, why can't it just work like this? Why do I have to do my .then? Boom. What await does is await sees this asynchronous piece of code right here. It sees this promise, and it will wait for it to finish, and it will stop running the code within this function until that is resolved, and then it will put it inside of the hubs variable for us. So this will actually be equal to the array of hubs, just like the argument to our .then is. That's what async await does. Now, we're able to kind of block the code within this function on this line and prevent anything else from running it until it's done because of our async keyword, right? As soon as this function tries to execute, JavaScript is essentially going to wrap it in a promise for us and let it go into the background. Whereas if we, wanted to do something similar to an await in non-asynchronous code, then we'd stop our whole program from running, and that's generally something that we want to avoid. So now that I have my hubs here, I can just say res.status 200.json and give it the hubs. And I can comment out the promise-based approach, and we can check and verify that this works. Exactly the same as the other one does. That's pretty neat. Does anyone have any questions about this?
Yeah, since it's continuously running, does it take up more memory to use async?
No, it doesn't take up more memory. It's just basically another way for us to express how we want to handle asynchronous code. Either way, we're going to be backgrounding some amount of code, like when we do our .thens and our .catches, right? We're executing the hubs.find in the background, and then when it finishes, JavaScript is going to come and execute the .then or the .catch. So we're still backgrounding some amount of code where we're waiting on things to run. We're just doing it on this function level rather than like this function level. So I do not believe there is a significant performance difference. And if there is, it's one of those things where premature optimization is, bad. Chances are, like, the thing that you're going to spend almost all your time doing is trying to get things out of the database, right? This is the expensive part. This function being asynchronous, not the expensive part. So we usually don't have to worry. Okay, so then Faye asked, this seems very useful and takes a lot less typing. Is there a benefit to using promises instead of this? Well, the async await is somewhat newer than promises. I like some of the semantics that promises have. And also, like, sometimes I don't want to make my whole function asynchronous. I'll just do the whole promise thing. One of the other trade-offs is what Catherine has asked, which is, what do we do if there's an error, right? So we don't have a .catch equivalent in here yet. And what we can do with async await, and this is not a part of async await, is this construct called try and catch. And the idea is that we can wrap a block of code inside of this try block. And what this will do is it will execute this code. And if it does what it's supposed to, that's fine. Everything is all right in the world. But if anything within here throws an error, instead of that immediately bubbling all the way up and hitting our terminal and crashing our program or whatever, we're going to catch it. We're going to snag that error and have access to it inside of this catch block. And so here I could console log the error, and then I can do my res.status 500. I'm just going to copy and paste what I had before. And now I can handle my error this way. So it does end up being a pretty equivalent amount of typing once you add back in error handling, right? Because everything looks so smooth if you don't have any errors, right? Oh, beautiful. So sure. We could even put, this right in here. Don't even need an intermediary variable. But as soon as you add in error handling, our code gets a bit more verbose. Luis talked about on Friday There are some methods for error handling in Express that let us write code that looks a little bit more cleaner without manual error management everywhere, but fundamentally, error handling is what makes us write more code, not async, await, or promises. So, any other questions here? All right, so let's go and rewrite the next endpoint. So I have my my essentially find by ID endpoint, right? Getting the specific instance of the resource here. I'm destructuring the ID from the params because that's how I'd like to do it. I'm using our find by ID function, and then doing our standard .then and catch stuff, checking to see if the hub exists, and otherwise 404ing. So to rewrite this into async and await, I add the async keyword to my route handler function, and then I'm going to keep this ID thing here. Now I'm going to say const hub is equal to await hubs dot find by ID, right? Because I can essentially stop on promise code and wait for it to resolve with my await. Then I can check and see if the hub exists. If it does, well, actually, if it does, really my code isn't changing, right? I'm changing kind of the trappings around it. I'm changing the syntax. Instead of doing this .then, right, I've accomplished that with my await here. So really, everything inside of my .then is unchanged. We just needed access to the hub, and the .then let us have it. The await lets us have it in a slightly different syntax, so I can just copy and paste the existing code that checks to see if the hub exists. If it does, we're going to return a status code 200, and the hub is a JSON object. Otherwise, we're going to return our 404, right? The hub does not exist. And then, if we want to add error handling here, I am going to wrap the code that I want to try to execute and see if it has any errors inside of my try catch block. And then inside of my catch block, I am going to catch that error, and I'm going to do my error handling, which is, again, the same as the way I had it inside my promises. I'm going to console log the error for me, the developer, to see what's happened, and then I'm going to return to the client status code 500 and an error getting the hub. And now I can uncomment my promise-based code, and we can check and see that this worked. And there we go. There we go. So really, none of the quote-unquote important bits of our code are changing. None of the code that's really performing our logical stuff has changed. It's really the trappings around it. And that's why this is just a different syntax for handling promises. It doesn't really absolve us of the responsibility of doing all the express and database things that we need to do. Does anyone have questions with this?
Can we talk about error handling? Like so the code goes through, and I know like if it's with promises and async await, like if the code doesn't finish, it still like causes a problem. Like if it never gets a return, but then if it throws an error, it goes into the catch block.
Yeah.
What exactly is that? I get a little bit like, what is that error? What's the difference between not receiving any data and receiving an error? Yeah.
Okay, so with this async await style, all we're doing is we're kind of forcing our promises to behave like our standard procedural JavaScript code, where when we run a function, we wait for its execution and get the value back from there. So this whole function is just going to run top to bottom, and try catch. You know, it's not a async await thing. This is just a JavaScript thing. In fact, we probably should have been using this in you know, some other context where some code we could execute could potentially return an error. Just most of the pieces of code we've encountered that could do that are Axios and database calls, both of which are structured as promises. So we've been able to use our .catch. So when we hit this error here, right? We pop into this catch block. So let's say this line throws an error. We would pop into our catch block. We would console log the error. We would then return this status code, and then our function would keep running. If there was any code in here, the function would keep going.
So can you give an example of what an error would be? Like what would an error be that it could run into that would catch in the error block?
Let's implement post, because that's going to be the easiest way for me to trigger errors in the database, and we can see that happen here. So I haven't implemented the rest of these endpoints yet, and we can do them with async await instead of rewriting old promise-based code. So this is going to be pretty standard for our post. So I'm going to get the values out of our rec.body that I want to use, and I like doing my destructuring thing because that's the style that I like. Here for our hubs, the only value that the user is supplying is the name. So I'm going to get the name, and then I am going to use async await. So I need to add the async tag to my function. And now I'm going to call another one of my my model functions that I have called insert. And this is going to take the hub object that I want to insert, and so I'm just going to give it the name. Because I'm using async await, I can just await for that. And this should return the ID of the newly created hub. Now I want to wrap this in a try block and also a catch block. And it's not necessary that we wrap asynchronous code inside of try catches, right? It's not always necessary that we need a dot then and a dot catch when we're using a promise. We use these methods, try catch blocks or dot catches, whenever we're worried our code might throw an exception, which is frequent. And one of the reasons, we use promises is because we're running this code that, may not pan out. That's why we don't want to wait for it. But we don't necessarily need to do this if I'm 100% sure that this operation is always going to be successful. So I catch my error. I'm going to console log my error for me. And then I'm going to send back my res.status 500. Let's give them an error message that says error inserting hub. Okay. So now I have this post endpoint here where I was doing some pre-show testing. So let's try to insert a hub named test hub. And I forgot to return a positive response. So let's do that. res.status 200.json. And for now, we'll just return that ID because getting the hub after this kicks off the next part of the conversation that I want to have. So even though we never got a response back, here, we'll just do it with test hub 2. So I'll add this test hub 2. We'll see that this now has an ID of 22. And now I'm going to try to add this again. That's going to trigger an error because the way the database was set up is that every hub needs to have a unique name. So if I check my console where my server's running, we see that I've console logged this error. And it says unique constraint failed hubs.name. We have an error number here and a code. You can use these to do kind of some of the more advanced error handling patterns where you're allowed to construct your own errors and you can do different things based on the contents of errors. But for now, we're just returning our message here.
That makes sense. So the error being returned is just like if it returns data that's not like that's how it knows.
Oh, I see what you're saying. So an error is, I actually have this pulled up because I was going to talk about it. An error is another type of data structure inside of JavaScript. It's a class. It's a class of things. We can make new errors the same way we can make new dates and new arrays. And it has stuff we can add in here like the message, which is this part, and optionally file names and line numbers and stuff. The thing that makes errors special and why we refer to this as a catch is if we want to indicate something has gone wrong, like, where do I want to do this? So instead of doing this 404, what I can do is I can just signal that this code has failed in the way that I anticipated it to work, right? This hub doesn't actually exist. So if I want to propagate an error upwards, I throw an error, right? That's why this is called catch, is because we throw it. And it does this kind of bubbling up until it hits a catch or just the top level of our program, and in that case, it will crash it. So I want to throw a new error, and I'm going to give it a message that says hub with ID not found. And so now we're going to see this is going to get handled by this catch block. So let's go over here into get hubs, and let's try to get a hub that doesn't exist, hub 900. Now this gets handled by the 500 here, because I tried to produce and toss a new error up, and then my catch block caught that error and decided to handle it. And we'll see if we look in here, we have an error message, and it's saying hub with ID not found. And this is one of the ways that we can do error handling with an Express, is we can throw errors in certain cases, which the message we want and other information, and then we can have a function that wraps our route handlers and catches the errors and then handles them appropriately with the correct status codes and any other resolution that we want, like maybe trying to roll back some database transaction or something like that. But yeah, this is what we mean when we're talking about our code produces errors, is it's throwing an error. And we're allowed to do this. And we're allowed to actually make new kinds of errors. That's part of this MDN article here, too, is we can make new types of errors, by inheriting from the error class.
So that's what these libraries and databases are doing, is they've got code written in them that creates new errors and sends them back up.
Mm-hmm.
Okay.
And what we've been a little bit overzealous in some of our catching, because right now we're catching. You can also throw things that aren't errors. I can just throw other stuff, and that will be caught here. We can check and see what kind of error this is, and it's like, oh, is this a SQLite error? Okay, then I want to handle it. If it's not, then I might want to throw it back and let something else handle it. And that is what the code inside of Next is doing, is that it's creating a special database error that it's throwing. Does that make sense?
Yeah, that makes a lot more sense, because I know in other languages there's like there's a standard in, standard out error, and so I'm just like looking at this code and I'm like, what? Like, this is an error. It's like you've got this banana error in the catch, and it's like, well, what is that? And this just sheds a lot of light on that. So thank you.
Oh, you're welcome. You're welcome. And one of the other things is, technically, when I'm console logging these errors, we also have this console.error construct. That it's like a console log, but it basically does it to a special version of the log that is meant exclusively for errors, and that might help our logging capabilities to separate errors from, like, when we wrote the logger middleware that just logs data for us to look at. And that's one way we can do this. Okay. So let's keep going down to our post. So I've gotten the insert working, right? We're getting the ID, we're returning that ID in the positive case. Otherwise, we are throwing our error here. Now, again, everything gets a bit more complicated with error handling, because let's say I don't want to give them back the ID, I want to give them back the actual hub object. Well, I can do that with our async await code by doing const hub, and we're going to await, and we have a function hubs.findById, and I can give it that ID, and then I can send back the hub instead of the ID as JSON. So let's create test hub 3. We're going to post this. Great, now we get everything. And so this works, and this is totally fine. And this would be a case where we could method chain .thens, and it would look very similar ultimately. But we're not handling our errors specifically. If for some reason this threw an error, it would get lumped in with our error message for inserting the hub. And so there's two ways, well, there's very, very many ways we could handle this, but the two most straightforward ways without, trying to invoke some different measure of error handling solution is how we want to structure our tries and catches. So very much like us nesting our .thens and our .catches with our promises, I can nest tries and catches. So I can try to get my hub and then send it back. But if that throws an error, I want to catch that error. And then I want to console log my error. And I want to return a message saying hub inserted, but error fetching it, or something like that. So now we have these two different error messages, where it might be important to let the person know that technically the insert was successful, but something went wrong trying to get it. And now you see this looks very, very, very similar to our promise-based code, right? Where we have nesting. And one of the desires of async await is to kind of get away from that nesting, to make our code more procedural. There are ways around this. One of them is to do the more complex error handling here, where we could inspect properties of this error and then return different responses based on that. Or we can just try to write our code procedurally. So instead of having this here, why not have it here? Right? If this is running top to bottom, I should be able to do it just like this. And you can with just one itty-bitty minor detail of scopes. So ID is not defined within the scope of this try block. That's because it's defined up here. Inside the scope of this try block, I can get around this by just declaring the ID in my function scope and then reassigning it within the try block. And now I can handle this just straight up in order. I try to get my ID by inserting my hub into the database. I can handle errors for that. I try to get the hub back out of the database. If that fails, I can return an error for that. And let's verify that this works with test hub sequential. And there we go. And that looks good. And some people have strong opinions about avoiding nested tries and catches. There's absolutely cases where they're unavoidable. One of the ways you can help avoid nested try-catch blocks is just by writing, named functions. And one of the recitations last week, I wrote, a function that does exactly this part, where it, gets the hub based on the ID and then returns it, or 404s or 500s. And so we can isolate that code into its own function, and then we can be free to use it within this try and not worry about catching any errors from it, because we're certain that code is going to succeed, not in that it will do what our user wants, but that it will try to do what it's supposed to and then handle any errors that come up correctly. So that's one way to avoid nested try-catches. This is another way. We can also, again, go back to this style where everything is in one try block, and then we manage the errors inside of our catch block depending on what errors that they are. So lots of different styles here. Any questions with this? No? Oh, I see someone typing. Oh, and Catherine asked a question that I missed. How does this affect other middleware? It doesn't, really. Our async code and our promise code is very highly compatible in that when we give a function an async tag, it automatically makes this function return a promise. And then whenever we return from within an async function, that is treated as the promise resolving. So we're free to mix and match promise-based code. And in fact, if we peek into the model functions that Luis was kind enough to write for us, they intermittently use promises and asynchronous stuff. And that's totally fine, because at the end of the day, they're implemented the way that JavaScript handles the asynchronous code is via a promise-based system. But async await is just a syntax around that makes it, that gives us a different option as a developer on how we want to handle that. So you can write asynchronous middleware. I mean, we already write asynchronous middleware with thens and catches, but you can write it with the async tag. That's part of the point of there being this next callback function that we can call whenever we want to. Okay, so then Faye asked, is the scope of the try block different than the scope of the catch block, or does the catch block have access to the stuff defined in try? That is a great question. They are different scopes. Pretty much any time we have a set of curly braces, all variables are local to that scope, to that set of curly braces. So catch does not have access to ID if I define it like this. But if we use the ID that's declared in the function scope, then catch would have access to it. That is a great question. All right, cool. Any other questions? All right. We have a little bit of time left here. Is there anything that you all would like to see? I can implement another route or two, or we can talk about maybe like how would you handle Axios requests with async await or something like that. Okay, I'm briefly going to do Axios requests, as that idea just popped into my head, and I was like, oh, should be good to see. It's very similar, right? Whenever we're rewriting code from promises into async await, let's say I have an Axios.get, and we're getting just some endpoint. We'd do a .then, we'd get our res, we would do something, set value with res.data. Otherwise, we would, dot catch. Ooh, typing is hard today. We get the error, and then I would, set some error to be thing went wrong. So rewriting this into async await, instead of doing our dot catches, we would wrap this in a try catch block. We would perform our Axios.get, but we would save its value into a variable called res, and we would wait for the Axios request to finish. Then we can do whatever we want with our res.data. In the case that it fails, we handle that within our catch block. So these would be essentially equivalent. And it's yelling at me about this await because you can only use await inside of functions tagged asynchronous. You are allowed to, if we're in React and we're writing a use effect, right? This receives a callback function. How convenient for us that this is inside of a function already. So in order to use the async await based code, function is now asynchronous. There we go. All right.
I don't know if it's true or not, but I heard that async inside the use effect, like some people are stopping to use that.
I was just thinking about that. That might actually yell at you because I think the only thing you're allowed to return from the use effect callback is either undefined or a function.
So you just have to wrap it in another function, I think.
Yeah.
Is what
Yeah,
Yeah.
you could wrap this in an IIFE, um, or you would more than likely and this should be the style that honestly is preferred. You would write a function like get data, and then this would be an asynchronous function that contains your code.
Yep, that's what it was.
Yeah. So this is the preferred style anyway. One, in just the approach of like function names are a form of documentation. But also, yeah, useEffect would not like being an async function. And so this is one way to get around that. But then also, you know, this function has a name and you know what it's doing. Yeah, but that's how you would handle that within React. Anything else? Any specific endpoint that you all would like to see or something before I sign off here? All right. Well, then I'm gonna end this just a smidge early today. Thank you all so much for coming. Hopefully, this lets you read and write some different code. You know, it's very interchangeable, so feel free to try out and see what you like. You can use both within the same project, as we see right here. Technically, I actually wrote this insert function because the add function made it too easy on us by actually handling the whole find by ID thing, and I wanted to display that here. But you can make almost any function you want async and just roll from there. So, all right. I will see you all tomorrow.